Right, let's imagine putting x into the first function machine. When we get it through here, we're going to get 3x, and by the end, we're going to have 3x plus 15. If we do the same and put x into the second function machine, then here we'll have x plus 11, and then after we've times it by 2, we'll have 2 lots of x plus 11. So we're interested in when the outputs are equal, and we can set these two equal to one another. 3x plus 15 equals 2x plus 11. Multiply out the brackets. Minus x from 2x from both sides. Minus 15 from both sides. X is equal to 7. Why is there no other input that gives two outputs that are equal? There's a few answers accepted here, and one is to say that this only has one solution. Which we've just obtained. I did see that it accepts like saying that they're not equivalent. When they're equivalent, that means they're true for all values of x. But in this case, essentially, we have two straight line graphs that were also, they only intersect at one point. Something like that anyway for that one mark. Okay, we've got another function. Chooses a value of p and q so that if he inputs any number into both function a and function c, he'll always get two outputs that are equal. So let's put in, I'm not going to put in x this time because we already sort of dealt with that. Let's call it y. No, let's call it a. So here I'm going to get a plus p. I'm going to times it by q, so it's going to be q times a plus p. And this is true for any number that we put in. So we need to think about this. We've got a up here, it was 3x plus 15, but now it's going to be 3a plus 15. And we're saying it's true for any number, so it's going to be equivalent this time. It's going to be equivalent to q a plus q p. Let me just backtrack. So I've put the input into here. This is my output. I've said Kai is he always gets two outputs that are equal for any input. So I've set the output from function A equivalent to the output from function C because it's true for any value of A. And now I can compare and see what P and Q must be. So because I've got an A here, I can basically compare these two and I can see that it must be that Q is equal to 3. And that means this is going to become 3P, and then it must be, if I compare these two, that P is equal to 5. So I've basically shown that timesing by 3 and adding 15 is the same as adding 5 and then timesing by 3.